class, Mr. Mohidian here with a video of what we would have covered in class were it not for the delay. So we're going to investigate properties of certain kinds of parallelograms. To do this properly, we'll need four colors. So I'm going to use blue, red, orange, and purple. Actually, green and purple. Now, your colors may vary. If you don't have colors, it's not the worst thing in the world, but colors will make this a little bit easier. So in your foldable, the first item you have here is a parallelogram. So on the outside door here, which I can't really show you, but once you fold this thing up, you'll have parallelograms written over here and these slots. So this one right here is a parallelogram. So we're going to fill in its definition. So the definition of a parallelogram, this color splotch is sort of like a key or a legend, a color key. A quadrilateral with two pairs of parallel sides. So all I'm going to mark in this color is going to be its pair of parallel sides. By definition, that's what a parallelogram is. However, as a consequence of this definition, there are several properties. One of its properties, here in the second color, is that the opposite sides are congruent. So the definition is opposite sides are parallel. Property is that opposite sides are the same length. And we're not proving these because we've done a lot of proofs, and by now you get the idea that to prove this fact, you simply prove that, for example, the two triangles on either side of this diagonal are congruent, and as a result, CPCTC says corresponding parts are congruent. In green here, my third color, I'm actually going to mark both of these facts, because they both deal with angles. Opposite angles are congruent, so I'm going to go with the opposite angles as the same size. And the second fact says, well, actually let me go with both pairs. So opposites here to here are the same, and here to here are the same. The second fact says consecutive angles are supplementary. So what does consecutive mean? Consecutive means one after the other. So going around the shape, you go to one stripe and then double stripe and then one stripe and then double stripe. So that means that any two that are directly next to each other or consecutive will make 180 together. So this fact will be explored some more in class, but for now, keep it in mind that because these lines are parallel, same side interior angles are supplementary. And the final fact of the parallelogram is that the diagonals bisect each other. So remember in a kite, which we talked about the other day, one of the diagonals bisects the other, but not vice versa. Here they bisect each other. So for this long diagonal, I'm going to give that a certain number of ticks, and the same on both sides because this is the middle of the long diagonal. For the short diagonal, I'm going to give it a different number of ticks, but the same number on either side of the intersection because it's bisected. So you have two pairs of congruent parts there, again, also by using CPCTC. So this and this are the same, and this are the same. So all those properties, now that it's all colorful, are true of all parallelograms. Now everything on this chart is a parallelogram, so the next slide, here we have a rectangle. So on the outside door, you know what a rectangle. So the definition of a rectangle is this. It has four right angles. Notice it doesn't say anything about being parallel, it says nothing about its diagonals. By definition, it's simply a quadrilateral with four right angles. But what that means is, because it's a parallelogram, one of its properties is, as a result, everything from the previous part is also applicable. So my red here, I'm not going to mark all of those, I'm just going to mark some of the most important ones. Opposite sides are parallel, that's true because of the parallelogram fact. Opposite sides are congruent, also true because of the parallelogram fact. And we already have the angles here in blue, but keep in mind, are the opposites the same? Yes, they're both 90, in fact. Are the consecutive supplementary? Well, yes, because 90 plus this 90 makes 180. So you'll see all the facts from the previous parallelogram also apply here for the rectangle. So that means the diagonals also bisect each other, but before we get there, let's look at the diagonals feature for the rectangle, and that's that the diagonals are congruent. So notice that in the parallelogram, the two diagonals appear to be different lengths, 3 and 3 ticks and 4 ticks. In fact, one literally looks longer. But in a rectangle, as this thing straightens out to become upright, so to speak, a rectangle thereby has congruent diagonals. So this entire diagonal length is the same as this entire diagonal length. And what that means is, well, as a result, if they're all in total the same length, from being a rectangle, and they're also bisected because of a parallelogram. What that means is that all four of these smaller sections of each diagonal are all the same. So the same number of ticks indicates that all four are the same length. Contrast that with just a simple parallelogram. So there's the feature of the rectangle. Next we have the rhombus. So by definition, what is a rhombus? A rhombus is just this. Once again, doesn't say anything about parallel, doesn't say anything about the diagonals. But as a consequence of this feature, what that means by side-side-side congruence is that it has all the properties of a parallelogram. So once again, these blue lines imply that these lines are going to be parallel, just like all parallelograms are. What that also means is that opposite angles are congruent. So you can kind of see this looks similar in some regards to the previous, to the very first parallelogram. And what that also means is that the diagonals bisect each other. But they're not the same length. You can kind of see that visually, but if it were the same length, then it would be a rectangle, not necessarily just a rhombus. So all four sides are the same in blue, opposite angles are the same in red because it's a parallelogram, diagonals bisect each other because it's a parallelogram also. However, a rhombus is a special kind of parallelogram, and in doing so, it has some unique features. So one of its unique features that's only true for the rhombus is that the diagonals are perpendicular. So they cross each other at 90 degrees. That's true only for rhombuses, when it comes to parallelograms at least. Now if you look up here, you'll see that that's not the case for the rectangle because these two are different. And it's not the case for just any old parallelogram because one's obtuse and one's acute, it appears. But for the rhombus, they cross at 90 degrees. What else is special about the rhombus? The diagonals are angle bisectors. So what that means is, it's going to be kind of hard to show, that angle 1 and 2 are congruent because it's cut in half by this diagonal line. That also means is angle 3 and 4 are also congruent because the diagonal cuts that angle in half as well. So these angles are the same and these angles are the same. So you can have some symmetry with the rhombus you don't necessarily have with the rectangle or the typical parallelogram. As we saw from our family tree, or our Venn diagram, a square is simply a shape that is simultaneously a rectangle, a rhombus, and thereby a parallelogram all at the same time. So in theory, every single thing above the square page here is going to be true for this shape here. So to indicate that, by definition, what is a square? A quadrilateral with four congruent sides, so this, and this, all that comes from its definition, and four right angles, so this also comes from the definition. It's a parallelogram, so in my second color here, actually I think it's my third color, but in any case, in some color, a square is a parallelogram, so that means that the opposite sides are parallel. That's a feature that's true about parallelograms. Notice that opposite angles are congruent and consecutive angles are supplementary, just like we saw. It's also a rectangle, which means then that the diagonals bisect, so the diagonals are congruent. So one corner to the other corner is the same length as the other pairs of corners. So that means these are all the exact same length, just as we saw in the rectangle. So in a sense, the square inherits these red properties from its rectangle ancestor, right? Because it's one of the forefathers of the square. And from the rhombus, it inherits, of course, the fact that all four sides are the same length, but it also means that the diagonals are perpendicular, just like it is above here in the rhombus. What that also means is that these are angle bisectors. So angle 1 is the same as angle 2. And likewise for these and these. However, we can go one step further and say that both of them are exactly 45 degrees, because we know it's 90 because of the rectangle, and we know it's a rhombus, so it's also bisected, so half of 90 is 45. So hopefully in total here you get a better sense of the features of all parallelograms, as well as some unique features that are true only for special times. So these colors here hopefully can give you a sense for exactly why a shape has the properties that it does. All right, I'll see you in class.